diagrams are a way for scientists and engineers and technicians around the world to communicate with each other about circuits. Because we're talking about lots of different languages, quite often there are common symbols. In this video, you'll be introduced to several of those common symbols. Now, this is not an all-extensive list of common symbols. There are many, many more, but these are the ones that we'll use in physics class. For starters, for a wire, we just use a straight line. One thing that's really important about circuit diagrams is that all of our lines are straight in circuit diagrams. No curvy lines acceptable here. If we have two wires meeting, then typically they make a right angle. The second symbol that we'll learn about is a battery. A battery is symbolized by one long line and one short line. The long line always represents the positive side, while the short line always represents the negative side of the battery. If I have multiple batteries directly connected to each other without wires between them, then I just put those symbols right next to each other, as you can see on the right here. Resistors are represented by a zigzag line. The number of zigzags that you use is not important, so I gave an example using 4 and 3 here, and both of those would express a resistor. Light bulbs are one of the few elements that have multiple symbols for them. They always have a large circle, and sometimes the inside is kind of a loop shape. Sometimes there's an X on the inside, or sometimes there's a zigzag, much like a resistor. The final symbol that you're responsible for is a switch. In circuit diagrams, switches are always represented in their open position, as you see here, even when the switch is actually closed as the circuit is operating. If we were to draw the switch in the closed position, then it would look no different than a wire. Let's look at some examples. In our first example here, I have a battery, a light bulb, and a switch. You'll notice that sometimes with our symbol for switches, they have a dot on either end of the switch, but this isn't necessary. In our second example, I've got 2 batteries directly connected to each other and 4 different resistors. You'll notice that on either side of that resistor labeled R2, there's a dot where that wire connects to the other wires. Again, that's unnecessary. You could just draw it as one straight line kind of intersecting the other straight line. You'll notice in both of these diagrams, our wires always make right angles and everything is a straight line. While these are pretty simple diagrams, what we see in the real world is quite a bit more complicated. Here's an example. Now, while you definitely will not recognize all of the symbols in this circuit diagram, you'll notice that everything is made up of lines, straight lines to be specific. There are many resistors here and lots of other elements that are beyond the scope of our course. We'll have lots of practice drawing these ray diagrams in class. Being able to draw and analyze them is crucial to our understanding of circuits.